Hello, in this video I'll be going through the 2007 Haberdashers 11 Plus Maths paper. I will first just go through the answers, okay, so tell you the answers and tell you how many marks to give each question, right? It's actually important you understand how an 11 plus paper is marked most of the time, how the marks are assigned. Afterwards, I will go through what I think are the unique or difficult questions in this paper. Most of them are pretty standard, so I won't be going through things like 49 plus 37, but I will be going through some of these quite complicated questions towards the end. I already have videos about question 29 over here and question 30. They're quite long questions, quite difficult questions, so they needed their own videos. So I'll be going through some of the easier but still difficult questions on the paper. So for question 1 we have 86, then 57, then 348, then 1003, then 207, then 2864, 5, 9, we want this one here, right? So 999 over 1000. And for this one, for these questions where you have to choose out of a bunch of fractions and decimals and percentages, an equivalent fraction would not be allowed. So something like 9990 over 10,000, this would not be allowed, even though it is an equivalent fraction. I'll speak more about that later. Okay. Question 10, the answer is 4,995. 11 is 135. 12 is 270 meters. If you don't have the unit there, you don't get the mark. 13 is 7. Okay. Oh yes, I will just mention that in some versions of this paper that you will find online, there are typos in questions like question 3 and question 13, where instead of the multiplication sign, you will see something like an apostrophe. Okay, so just so you know, I've corrected that in the image that I have. Okay, now 14 should be 24, 15 should be 45 meters. Again, the unit is necessary. 16, the width should be 2 centimeters, and the length should be 12 centimeters. In 17, we have no, yes, no, and no. 18 should be 3 silvers and 4 coppers. 19 should be 24 here and 84 here. And oh yes, I'll just mention that on this page we're seeing questions that have more than 1 mark. Okay, how should these be marked? The ones here with 2 marks each, since the number of silvers and number of coppers are so dependent on each other, right? If all you've written is the answer and one of them is wrong, so let's say you've got the right number of silvers but the wrong number of coppers, you wouldn't get any marks unless you have some working. Okay, now of course I don't know what working you have, but if your working indicates that you had exactly the right idea of how to calculate the silvers and coppers, you had the right method, but you just slipped up and you got the wrong number of coppers, then you would get 1 mark. Does that make sense? But if you have only the answer, if that's all you've written, then they may be guesses as far as I, the examiner, am concerned. So if you have one of them correct, that doesn't really tell me that you know anything about this question. So you get no marks if only one of them is correct and you have no working. The same thing with this. It's the same idea with this rectangle question 16. Now this one here, number 17, these are independent of each other, these four. So it's basically 1 mark for each of them, and they're all independent. So if you get some of them wrong and some of them right, you get the marks for the correct ones, and you get no marks for the incorrect ones. Okay. Right. Let's move on. We have question 20 here, and question 20 has answers 20, 132, 6.6, 184, and yes, that's it. They're 1 mark each, and they're independent of each other. Okay. 21, we have 18, and B should be 9. Again, these two are independent of each other. 22, 3, 315 is the correct time. Okay. It should say 26 squared equals 25 squared plus 25 plus another 25 and plus 1. And this equals 625 plus 50 plus 1. This middle step you don't necessarily need to have in this form. It could say 625 plus 51 or something, right? I just put there to simplify the working. Frankly, you could skip this middle step altogether and simply have the answer, which is 676, right? So you need to have this first step because that shows that you have used this method and you've used this pattern, and they did say to use this pattern, so you have to do that. And then you need to have the answer, of course, to show that you've actually worked it out. But it's only 1 mark for this entire thing. So if you only have part of it, you don't get the mark. Right, 24. The 5th pyramid number is 55. The 6th pyramid number is 91. And the 7th is 140. What do we call these numbers that we're adding together to make the pyramid numbers? They are, of course, square numbers. Okay, square numbers. 25, the answers are £19, 80, £26, and £51.80. Okay, 3 marks independent of each other. 26 we have 20, 25, and 29. In part B, well, how can we get an 8? In the following ways, and all of these are important. We have 3 plus 5 and 5 plus 3, 4 plus 4, 6 plus 2, and 2 plus 6. Right, so this is a 2 marker. The way this works is if you've missed out one of these, then you can have 1 mark. But if you've missed out 2 or more, you get no marks. Right, so if you have all 5 possibilities, then you get 2 marks. If you have 4, you get 1 mark, and any fewer than 4, no marks at all. I will come back to this question and explain it later. 27, we have 5 miles per hour. Again, you need the unit here, otherwise you don't get the mark. And part 2 is 15 miles per hour. Now, here, if you have only the answer, you can have both marks. But if you have the incorrect answer and you have some working, it really would depend on your working. Okay. If your working shows that you are doing the right thing, but you slipped up somewhere, then you can have 1 mark. Okay, 28. Again, you're given a method here that you have to use in 2 new cases that they present to you. And what you want to write here is 100 times 101 divided by 2 equals 5050, right? And in part B, what you want to do is start with the 5050 you worked out in the first part and take away the sum up to 49 terms. So 49 times 50 divided by 2. And if you work this out, you end up with 3,825. Okay, so it's 1 mark each, and in both of these, since you're asked to use this method and it's underlined, you need to have this part, okay? Simply the answer is not enough. You must show that you have used this pattern here and understood that pattern. Right, and finally for 29 and 30, I'll just give you the answers, and as I said before, I will not be going through them later. You can look at the separate videos I already have up on my channel. 4, 4, 6 is already there. We have 6, 8, and 12. 2, 1, and 1. And finally 7, 5, and 10. The connection between n, r, and a is n plus r equals a plus 2. You're allowed here rearrangements of this formula. So if you wrote something like n plus r minus a equals 2, that's okay. Okay. I will mention in this video that this is something called Euler's formula, and it's very famous. It's kind of cheeky for the writers of this 11 plus exam to put it here, but it's something that you can work out from the table, as I explain in my other video. Euler's formula. I'll mention one more thing. I found a mark scheme online that shows that says as the answer something like, as the number of regions increases, the number of arcs increases, or something like that. And even though that is true for these sort of limited examples, that's not really a precise enough relationship, right? Precise enough connection between n, r, and a, okay? Or perhaps it said something like when you add together n plus r, as that sum goes up, so does the number of arcs. Again, it's true, but it's not precise enough. Really, you want to notice that when you add together these two, you get 2 more than the number of arcs. Right? So 6 plus 8 is 14, minus 2 is 12. But again, more on that in the separate video. And finally, question 30, the answer should look like this. We want 9 here, we want 20 here, and the table should be 0 here, 9 here, we've already done that, 20 here, again, we've already done that. There should be 170 in the last box, and here I'll write it. I would write it like this if I were you to fit it in more nicely, but it's n times n minus 3 divided by 2. Yes, so I explain all of this in my other video. The way you should mark this is, as you can see, there are 5 boxes you need to fill in, and each of those are independent. Okay, so you get 1 mark for each, and you drop 1 mark for each incorrect one. Pretty straightforward. Similarly here, these 2 marks are independent. Oh yes, I should mention how you should mark this table over here in question 29. The way you should mark this is if you have any mistake, you drop 1 mark for that mistake. Okay, so if you got 3 of these wrong, let's say you got all of row 4 wrong, you get no marks, even if you had these 2 correct. Okay, that's usually how marking works for these tables, right? it's not going to be a 9-mark question. It's not that difficult, right? So it's probably a 3-marker, and every mistake you drop a mark, because you shouldn't really make mistakes here. It's just counting. That's the logic there. Okay, so that is the mark scheme. We will now be going through the more difficult and interesting questions on this paper in detail. There's a little comment I want to make about questions like this, about ordering a bunch of decimals, percentages, and fractions. You will see this, it's almost guaranteed you will see this in one of your tests. And please, as your answer, I know that when you're doing the working out, most of you will probably convert them all to fractions, or all to decimals, or all to percentages, and then compare them, and then choose the smallest or biggest, right? In this case, we're looking for the number that's closest to 1, right? So probably you will all convert this to, let's say, fractions, and then find the one that's closest to 1. When you write your answer, some people make the mistake of keeping it in that converted form, right? So let's say we made these all into decimals, okay? Then 999 over 1,000 would be 0.999. And of course that is equivalent to this fraction, but to write 0.999 here would be a mistake, okay? Because that is not the form in which it is given to you. So even if in your method you convert all of these numbers to a different form, make sure that in your answer you give it in whatever form it is given to you, okay? Right. About questions like this, where there's an approximation, some people had, well, a lot of my students had trouble with this. I mean, it's a little annoying because there are 2 different types of number and you have to approximate both of them. You know, if they were both decimals, perhaps you'd be thinking, let's round them both to 1 decimal place or something like that. But here one is a fraction, the other is a decimal. But the thing is, it's so obvious what you should round these to, because this, it's just so close to 500 over 1,000, which is equal to a half. And this, it's just so close to 14, right? So finding the approximate value of this times this is clearly just a half times 14, and therefore it's 7. Okay, right. Yeah, I think these are all relatively easy. Oh yes, so let's look at this question 23. This is relatively unique. Now, if you've done algebra and expanding quadratic brackets, then you know what's going on here, right? What's going on here is 1 plus 1 squared, for example, is the same thing as 1 plus 1 times 1 plus 1, written like this. And when you expand these brackets, you multiply them out in this order, giving you 1 squared plus 1 times 1 plus 1 times 1 plus 1 squared, right? Of course, that ends up being just 1 plus 1 plus 1 plus 1, right? So they want you to notice this pattern, though, even if you don't know quadratic expansion, okay? So they want you to look at this and notice, okay, what's going on here? Well, whatever these 2 numbers are, it's a little hard to tell with 1 plus 1, so let's look at 2 and 1 because they're different. So it looks like we have the first number squared, then the first number, then the first number again, and then the last number. So let's say that's the pattern. And now let's check it with 3 and 1. It seems to work. First number squared, first number, second number. Okay, and it works for 4 as well. So clearly that's the pattern. Now we just need to use that to work out 26 squared. Now, we need to make the connection here, right? That these brackets, all of them, of course, equal 2 squared, 3 squared, 4 squared, and 5 squared, right? So what's happening is we have a square, we break it up into 1 plus the number one below that square, or the number that you're squaring, and then you apply this pattern. When I see 25 squared and 26 squared, what I'm thinking is clearly 26 squared here has been broken up into 25 plus 1 squared, like this, right? And now I can use the pattern. The first number squared, plus the first number, plus the first number again, and plus the last number in the brackets. And now you can see that the answer we wrote down just shows the rest of the working. You add these up and you get 676. Okay, so essentially what they've taught you in this question is a way to convert a slightly more complicated calculation like 26 squared into adding together 25 squared, 25, 25, and 1. Plus they already give you 25 squared, right? You don't have to work that out yourself. Okay, so I hope that helps with that. And the next such is question 24, concerning pyramid numbers. I think many people who study square numbers as sequences come across the fact that to get the sequence of square numbers, one simply starts with 1 and adds the next odd number every time to generate the next square number. What I mean by that is that if you look at 1, 4, 9, 16, 25, and so on, if you look at the first difference in this sequence, the first difference is what we call the sort of secondary sequence of differences between consecutive numbers. We see that we get 3, 5, 7, 9, and these are simply the odd numbers. So that's what I mean. To get to the second square number, one adds the second odd number to the previous square number. 3 is the second odd number because 1 is the first and 3 is the second. I think that's clear. And this is a good pattern just to know, okay? You can get the next square number by adding an odd number. But what happens if you add the square numbers together, right? What sequence does that generate? Well, that's the sequence of pyramid numbers, okay? So if we list the pyramid numbers, they give us here 1, 5, 14, 30. And we find the sequence of first differences. We get 4, and then 9, and then 16. You see, these are the square numbers. And so the next one will be 30 plus 25, which will, of course, be 55. Okay, and that's why the fifth pyramid number here is 55. Add 36 to that, you get 91. Add 49 to that, you get 140, and so on and so on. That's why the answer to this, what do we call the types of numbers we're adding to get each of these pyramid numbers, is square numbers. Okay, that's what we're adding. And, even if you didn't know all this background about square numbers and odd numbers and pyramid numbers, it's pretty clear from the way they sum, at least this one, it's extremely clear with the fourth pyramid number, that we're adding square numbers here. Okay, and clearly one more square number every time we move up to the next pyramid number. Okay, the reason these are called pyramid numbers is, well, they look like pyramids if you kind of draw them. Let me give you several examples of numbers named after the shape they make when you draw them as dots. For example, triangle numbers are called triangle numbers because they make triangles. Okay, so the triangle numbers are 1, 3, 6, 10, right? And we get the next triangle number by adding the next whole number, right? So 1 plus 2 plus 3 plus 4, so on and so on. The square numbers, well, there are several reasons they're called square numbers, but one reason or at least one reason it makes sense to call them square numbers, is because they make squares. Here's the first square number 1, the second square number 4, the third square number 9, and so on and so on. Now, I hope you can see this picture, and this is what we will need to visualize pyramid numbers. A 2D picture is no longer enough, as it was for square numbers and triangle numbers. You see, if you make these layers out of 3D spheres, layers in the shape of squares, each layer containing a square number of spheres, so 1, 4, 9, 16, it is easy to see that you can stack these on top of each other and make a pyramid. I don't know if you've ever had a toy, perhaps, that's made up of lots of little spherical magnets, but I think you might know what I'm talking about. So, I don't know if you can see, but there are exactly 9 of these small divots in the surface of the layer with 16 spheres, and you can see that these 9 spheres in the next layer will perfectly fit into those dips in the surface. And similarly, into these 4 dips, these spheres will fit perfectly, and into this one dip, this one sphere will fit perfectly. Okay, so that's how these pyramids are constructed, and this is why they're called pyramid numbers, and this is the visualization of why pyramid numbers are obtained by adding up square numbers. Okay, so I hope that this has been a useful overview for you. I'm sorry for the crudeness of the cuts and the jumping quality and volume of the voice. That's something I'm going to fix in my future videos. Thank you, and I'll see you again.